In this video, we will learn about common ions and how to write the chemical formulas of ionic compounds. By the end of this video, you will be able to recall the charges of common positive and negative ions, identify polyatomic ions, and also write the chemical formula of ionic compounds correctly. Let's begin. Positive ions are called cations. They are formed when atoms lose electrons. In general, metals tend to lose electrons and form cations. The charge of their ion is related to the group number of the element in the periodic table. Let's look at some common examples. Group 1 elements form ions with a charge of positive 1. For example, sodium ion forms a charge of positive 1 and we write the ion as Na+. For potassium, it forms a charge of positive 1 and the ion is K+. For group 2 elements, they form ions with a charge of positive 2. Magnesium ion has a charge of positive 2 and the formula is Mg2+. For calcium ion, the charge is also positive 2 and the formula is Ca2+. Group 13 elements form ions with a charge of positive 3. For example, aluminium ion, its charge is positive 3 and its formula is Al3+. Transition elements, which are found in group 3 to group 12 of the periodic table, can form ions with variable charges. For example, iron can have charge of positive 2 or positive 3, which is Fe2+ and Fe3+. For copper, they can have variable charges, positive 1 and positive 2, which gives us Cu+ and Cu2+. There are some exceptions. Some transition metals usually form only one common ion. For example, zinc. Zinc ion mainly comes in charge of positive 2, hence its formula is Zn2+. For silver, the charge is mainly positive 1, hence is Ag+. One ion worth noting is the hydrogen ion, H+. Hydrogen is special. Now, even though it's a non-metal, it can still form positive ion, H+. Most other non-metals form negative ions by gaining electrons. Negative ions are called anions. They are formed when atoms gain electrons. In general, nonmetals tend to gain electrons and form anions. Group 17 elements form ions with a charge of negative 1. You realize that when these elements form ions, there's a change in their name. So for group 17 halogens, we'll remove INE and replace them with IDE. So for example, instead of fluorine, we will call the ion fluoride. Same thing for oxygen. Alright, so for group 16 elements, we will actually change its name from oxygen to oxide. So remove part of the name and replace it with IDE. For nitrogen, we call it nitride. We'll replace part of the name with IDE. So for chloride, F-, chloride, Cl-, bromide, Br-, and iodide, I-. Group 16 elements form ions with a charge of negative 2. Oxide is O2-. Group 15 elements form ions with a charge of negative 3. Nitride is N3-. A polyatomic ion is an ion that is made up of 2 or more atoms joined together and carries an overall charge. Now here are the common ones you need to remember. Ammonium ion, it has a formula of NH4+. It means that there's one nitrogen, four hydrogen, they are covalently bonded together, and the overall charge of this ion is positive 1. Hydroxide, OH-. For nitrate, NO3-. Sulfate, SO4 2-. For carbonate, is CO3 2-. For sulfide, SO3 2-. Now these are very important polyatomic ions that you should remember, as they appear quite often in exams. When writing the formula of an ionic compound, we follow these steps. 1. Write the formula of the positive ion and the negative ion. 2. Write their charges. 3. Balance the charges so that the overall compound is neutral. 4. Write the final formula. We do not write the charges in the final formula. Let's look at some examples. Example 1. Sodium chloride. Now sodium is in group 1, so it forms an A+ ion. Chlorine is in group 7, so it forms chloride ion, which is Cl-. Now look at the charges. One positive charge and one negative charge. They balance each other perfectly. So the formula is NaCl. Next, magnesium oxide. Magnesium is in group 2, so it forms Mg2+. Oxygen is in group 16, so it forms O2-. To make the total positive charge equal the total negative charge, we will need to use the cross method. Now bring the charges down. The ratio is 2:2. This can be further simplified to 1:1. This simply means that we need one magnesium ion and one oxide ion to make overall charge 0. So the formula is MgO. The next example, aluminium oxide. Aluminium is in group 13, so its ion has a charge of positive 3, so it forms Al3+. Oxygen is in group 16, so it is O2-. Here the charges are not the same, so one aluminium has a charge of positive 3, while one oxide ion has a charge of negative 2. So same thing, we'll use the cross method. So it is to make the total positive charge equal the total negative charge. Now we bring the charges down. So this means that we need 2 aluminum ions to balance the charge of 3 oxide ions. So 2 times positive 3 gives us a charge of positive 6 that comes from aluminium ions. And 3 oxide ions times the charge of oxide, which is negative 2, it gives us a charge of negative 6. Now the overall positive 6 minus 6 is actually 0. So the charges are now balanced. So the ratio of this ion should be 2:3. This means that we need 2 aluminum ions and 3 oxide ions to make the overall charge 0. So the formula of this ionic compound is Al2O3. Now let's try one with a polyatomic ion. We are going to try calcium hydroxide. Now calcium forms Ca2+, hydroxide ion is OH-. Calcium has a charge of positive 2, while hydroxide has only negative 1 charge. Now to make the total positive charge equal the total negative charge, we will use the cross method. Bring the charges down. The ratio is 1:2. This means that we need 1 calcium ion and 2 hydroxide ions to make overall charge of 0. So when we write the formula, we put brackets around the hydroxide ion because it's a group of atoms. Now the formula becomes CaOH bracket 2. Last example, iron 3 sulfate. Now remember, iron is a transition element, so it can form ions of different charges. The name itself tells us it's iron 3, so the ion that we are dealing with now is Fe3+. Sulfate is SO4 2-, As mentioned, you should memorize the formula of the polyatomic ions. So the charges are different, +3 and -2. We'll use the cross method to make the total positive charge equal the total negative charge. So we bring the charges down. Ratio is 2:3. So 2 iron 3 ions means that there's 2 times +3, which is +6. Alright, and 3 sulfate ions is 3 multiplied by -2, which is -6. So 6 minus 6, which gives me a 0. So the overall charge is 0. So the formula is Fe2SO4 3. So notice that we put brackets around the sulfate ions because it is a polyatomic ions. So we write a 3 outside this bracket. Now we have gone through several examples. Now to test your understanding, I would like you to pause the video and try writing the formulas for these compounds. Now resume the video when you're ready and we will check the answers together. Welcome back. Let's check the answers together. Sodium nitrate. Sodium is in group 1, so it forms Na+. Nitrate is a polyatomic ion with a formula NO3-. The charges are +1 and -1, so they balance each other. The ratio is 1:1. So the formula is NaNO3. Calcium carbonate. Calcium is in group 2, so it forms 2+. Carbonate is a polyatomic ion, which is CO3, 2-. Now the charges are the same, +2 and -2. The ratio is 2:2, which we simplify to 1:1. So the formula is CaCO3. Next one, aluminium chloride. Aluminium forms Al3+, chloride forms Cl-. One aluminium ion has a +3 charge, while each chloride ion has only -1. Let's bring down the charges. The ratio is 1:3. So it means that to balance the +3 charge, we need 3 chloride ions. So the formula is AlCl3. Question 4, copper 2 oxide. So copper, we know that it is a transition metal. So copper is capable of forming different charges, okay, copper 1 and copper 2. So from here, the name itself, it tells us it's copper 2, so actually we are dealing with Cu2+. Oxide, okay, it must be O2-. The charges are equal, +2 and -2. The ratio will be 2:2, which we can simplify to 1:1. So we just need 1 copper 2 ion to balance the charge of O2- ion. Alright, so formula is CuO. Next, ammonium sulfate. Ammonium ion is NH4+, sulfate ion is SO4 2-. Ammonium has a charge of +1, while sulfate has a charge of -2. So to balance the -2 charge, we need 2 ammonium ions. So the ratio is 2:1. So when we write the formula, we put the bracket around the ammonium ion because ammonium ion is a polyatomic ions. It means that we need 2 groups of ammonium ion to balance the charge of 1 sulfate ion. If you find this video useful, please subscribe to the channel and like the video. Don't forget to share the video with your friends. If you would like to have more chemistry resources, you may check out my website. The link is in the description. Have fun learning chemistry, and I will see you soon.